Find the square roots of a complex number 4 root 3 plus 4i and graph in degrees. The complex number given is z equals 4 root 3 plus 4i, where the real part a is 4 root 3 and the imaginary part is b equals 4. To find the square root is to find z to the 1/2 power. And we know that there are two distinct solutions. We will use the n-root complex number formulas, which state that the n-root of z is the n-root of the modulus times cosine of theta plus 2k pi over n plus I sine of theta plus 2k pi over n. And in this case, since n equals 2, we will use k equals 0 and 1 only. But first, we would need to find the polar form of this complex number, so we would need to know the modulus r and the argument theta, where r squared equals a squared plus b squared, where a is 4 root 3 and b is 4. 4 root 3 squared is 4 squared times 3, and 4 squared is 16. This is 16 times 3 plus 16, or 48 plus 16, which is 64. R squared is 64, so r equals the square root of 64, or simply 8. 8 times 8 is 64. So the modulus of this complex number is 8. To find theta, we first find tangent of theta. Tangent of theta is b over a, or y over x. b is 4 and a is 4 root 3, and we recognize that this complex number is in the first quadrant, with a being positive 4 root 3 and b being positive as well, 4 root 3 on the real number line and 4i on the imaginary line. So this is a number in the first quadrant. Simplifying tangent, we have 1 over root 3, and since this is an angle in the first quadrant that we're looking for, we will keep this at I over root 3, and the trick is to divide it by 2, top and bottom. Tangent is y over x, so we know that the point on the unit circle is x equals root 3 over 2, y equals 1/2. And the only angle theta that satisfying the terminal point is pi over 6, but in degrees, this is 30 degrees. Now that we have the polar form of the given complex number, z equals 4 root 3 plus 4i, which is 8 times cosine of 30 degrees plus I sine of 30 degrees, where the modulus r is 8 and the argument theta is 30 degrees. To find the square root, we use the n-root for complex number. We're also asked to provide the solution in degrees. When k equals 0, the first solution, z sub 0, is the root of the modulus, which is the square root of 8 times cosine of theta, but theta is 30 degrees, plus 2 times 0 times pi, which is 180 degrees, over 2, plus I sine of the same angle, which is 30 plus 2 times 0 times 180 degrees over 2. Observe that to use degrees, instead of using 2k pi, we can simply use 360 degrees times k will work as well. Simplifying this, we have the square root of 8 is 2 root 2. Cosine of 30 plus 0 over 2 is 15 degrees plus I sine of 15 degrees. And this is the first solution when k equals 0. When k equals 1, the second solution is root 8 times cosine of 30 degrees plus, this time with k equals 1, 1 times 360 degrees is 360 degrees over 2 plus I sine of 30 degrees plus 2 times 1 times pi, or 360 degrees over 2. This is 2 root 2 times cosine of 390 degrees over 2 plus I sine of 390 degrees over 2. This is 2 root 2 times cosine of 195 degrees, because 390 divided by 2 is 195, plus I sine of the same angle, 195 degrees. And we can leave the answer in this form because the question is asking for the answer in degrees. To graph this, we know that there will be 2 points on the circle. They are equally apart. The first one is at the angle 15 degrees. And the other one is 195 degrees, which is 180 degrees, and add 15 degrees more. So we have 2 solutions. This circle has the radius of 2 root 2.